Logan, we're live. How's it going, man?
Doing great.
Good. Hey, everybody. Welcome to another episode of Swagelok Southeast Texas Talks. I am your host, Buster.caballero, along with my other bearded brethren. We're live right here, logan.boatright. Man, how are you doing today, Logan?
Doing great, man. It's just waiting for the weather to hit, looks like.
I
But
know.
other than that, it's going great, man. So what dig into the show. So we recently had on Jake Jones a couple weeks ago to talk about some of the components that we have that can help out rotating equipment guys out in the field at our plants. But today we're digging a little bit deeper into seal support systems and our local capabilities with Swagelok Southeast Texas. And we have Brandon Dickerson on today to join us. So, Brandon, welcome to the show, man.
Should be popping on right now pretty soon. There he is. How's it going, man?
How y'all doing?
Great.
Good deal.
So, well, Brandon, man, the way we like to start these shows off is first of all, thanks for taking your time out to come and talk to us. But man, give us your background, give us your origin story. How'd you end up here?
Yeah, man. Well, first of all, thanks for having me on, guys. Glad to have the opportunity. But yeah, I'm Brandon Dickerson. I'm a field engineer here with the Swagelok Southeast Texas Assembly Solutions team. And basically, in a nutshell, what we do is we help our clients design and assemble fluid handling systems. Typically, these are custom in nature. If there's a unique challenge or an application that requires a non-standard offering, we can provide support in both design, building, and testing those assemblies in our local shop. So personally, I'm from Waco, Texas. I graduated from Texas A&M, class of 2012. Um, Engineering student. I've been in sales my entire professional career. Yeah, whoop.
You got to do it. You got to do it when it happens. So
Yeah, I've really my professional career has been focused around rotating equipment. So I worked with a pump company out of college for a year or two. Worked with a compressor company for a while there, and of course, both of those technologies implement our seal support systems we'll be talking about today. So been pretty familiar. Been in the industry for quite a while now, and just continuing to learn and apply those experiences to customer applications.
Awesome. So, seal support systems, and some of our customers call them seal flush plans, whatever specific name that we have for them. What's the purpose of a seal support system, Brandon?
Gotcha. Yeah. And so, Logan, that's a good point there. They can be called a variety of things: a seal support system, a piping plan, a flush plan, a quench plan, a seal pot assembly. The terminology that's out there in the field varies from customer to customer. And our experience and knowledge gives us the expertise to identify maybe what they're talking about and try and get it on paper and help them design it. But essentially what a seal support system does is it protects the mechanical seal by lubricating the seal. It provides temperature control and for the seal, flushes dirt, residue buildup, and or particulates away from the seal faces. It also, importantly, prevents process fluids from leaking to atmosphere, which ensure compliance with all regulatory requirements. And of course, when we mention the mechanical seal is a sealing device that's usually integral to a rotary pump, a centrifugal pump, and then some gas compressors as well. So essentially, again, in a nutshell, the seal support system is just providing protection, lubrication, temperature control for the mechanical seal itself. Mechanical seals are typically a costly item, and with proper seal support functionality in that system, you can minimize downtime from seal failures or, I guess, pump operational failures through supporting that mechanical seal. So it's a very important piece of the puzzle. Of course, downtime is the enemy there, and that seal support system is what keeps that pump up online running.
So, just follow up question, real quick, Brandon. Does every pump have its own seal support system on it?
So In terms of external seal support systems, not necessarily. There are pumps that simply take the process from the suction or discharge side and circulate it through the mechanical seal chamber within the pump itself. Now, those pumps do typically have plugs or ports where you can, at a later date, add a circulation style system. And, this is all based upon the specifics of the pumping application, the process fluid, the mechanical seal, and what that application might see. So those recommendations are made by the mechanical seal manufacturers or the pump manufacturers as they have a more intimate knowledge of what that particular seal will be seeing on a daily basis. So again, to circle back to your question, yes, there is some sort of support system for each mechanical seal. It does vary from application to application, where it's an internal system, an external system, a pressure fed system. And there's definitely a wide variety of ways that we can support or basically get lubrication and temperature control to that seal.
Thanks, Brandon. So, you mentioned a few things so far here. You mentioned the pump or the piece of rotating equipment. You mentioned this mechanical seal. Well, we're talking the seal support system or the seal support panel, the quench, on that side. Now, is this a piece of equipment or an assembly that usually comes with the rotating equipment? Is this something that is done separately? And can these be ever upgraded? How does the seal support system come into play when somebody's, I guess, I'm ordering a pump, I'm in rotating equipment, I need a new pump, I need the seal to go with it, I need the seal support system. Where does that seal support system come in on that?
Yeah, well, there's, of course, there's different circumstances and different situations can call for different things. So typically an end user could go directly to a pump manufacturer and say, hey, I had this application, I need this much flow, this much pressure, here's the process fluid and some other parameters. Select me a pump. That manufacturer would then select the pump. They would then work with the mechanical seal manufacturer to select the appropriate seal for that application. And that seal manufacturer would likely recommend a seal support system, basically a plan style, like a plan 11, plan 31, plan 72, whatever they feel is most suitable for that application. Now, at that point, the pump manufacturer could, one, give the entire pump package, which would include the seal support system. So that would be a complete package that's coming out of a capital expenditure, pump, skid, and seal support system. But then you would have some end users that might do the installation themselves. So they buy the pump from the manufacturer, do the same process. They get a mechanical seal chosen. The mechanical seal manufacturer then specifies the API seal support plan to be used. That end user could theoretically buy the seal support system from the mechanical seal vendor or the pump vendor, or someone like, say, Swagelok, who would come out and provide them with a panel, help them design it, build it, test it, and then they could install it on site. And then furthermore, you have the, of course, replacement, upgrades, and maintenance portion of it. So as we mentioned earlier briefly, there are pumps that have plugs that you can retrofit later on or add a circulatory system to it. So you can basically go from a pump that has an internal circulation system, decide later, hey, we want to change the process a little bit. Then you can add an external circulation system. And then, of course, the traditional replacement of worn or non-operational parts, upgrades, and then just typical preventative maintenance. So there's a pretty good variance in terms of how these seal support systems can end at their final destination.
So to kind of add a follow-up question on that, I know a lot of our customers, and we're talking with the rotating equipment group, that they will keep extra pumps sitting on the shelf just in case. Would they also be keeping an extra seal support system on the shelf?
Yes. Yeah, that could definitely be a possibility. Of course, responsiveness, quick turnarounds, and the elimination of downtime is our customers, some of our customers' target initiatives. They don't like to lose money, and having replacement parts on the shelf or replacement systems in this situation can help mitigate downtime, maintenance issues, things like that that are unforeseen in their operational day-to-day duties. So I guess the only challenge in that is whether or not you have a standard system or a custom system.
Okay.
Typically, people will, of course, try to stock replacement parts that can cover a variety of applications. If you have a more specific application with some specific flow meter ranges or temperature requirements, then that's where we can actually come into play with our product availability and configure systems on the fly to get you a quick turnaround. But you can stock systems on your shelf. It is advantageous in terms of predictability and risk mitigation. But again, it's you got to kind of weigh the costs versus the benefits of keeping spare systems on your shelf. But we recommend it for sure. It's definitely better to have it and not need it than need it and not have it.
Yeah, that's the case with a lot of things out in these plants.
Yeah, right.
So this is kind of a loaded question because they're all a little bit different. But what does a typical seal support system setup look like? What are some of the things that you're going to see in them?
Yeah, and that's a great question, Logan. So I'll just boil it down to a very simplistic, I guess, theory, and it's essentially what are we doing with the seal support system? And all we're trying to do is we're trying to transport some fluid from a point A to a point B, and then recirculate it through the system to make sure it's fresh. So it's just a simple fluid handling system. You'll see things like ball valves, needle valves, pressure gauges, temperature gauges. You can see regulators, pressure regulators for the nitrogen-fed systems, filters, needle valves, I believe I mentioned, flow meters, flanges. Of course, the components that Jake talked about, I think a week ago, the MEP components, we've come up with those components specifically for seal support systems where we found that we could optimize some of the connection points, minimize possible leak points, and just enable customers to efficiently and quickly install these components, whereas other solutions might be 2 or 3 piece solutions. We've tried to implement 1 piece solution. So our core components, Swagelok's been manufacturing for years, the quality, the reliability that you've come to love, all of these components make up a seal support system. And that's why we can supply these systems to customers, because we are fluid handling experts. We don't manufacture mechanical seals and we don't manufacture pumps, but moving fluid from one point to another, we are experts at that. We have the knowledge and the experience to help our clients solve those challenges. And then furthermore, the value that Swagelok Southeast Texas provides is in the flexibility and design. So if a customer has a specific application and they can't be boxed into a standard, or they want some additional instrumentation for their own data collection, whether it's temperature, they want to check on the state of the process after it leaves the pump chamber, or whatever it may be, we can add, change, retrofit, modify these plans for the specific customer's needs. So that's kind of the additional value that we bring, that we don't necessarily need to be in a standardized product. We have flexibility and can be responsive to customers' needs.
So with all that, one of the things that get thrown out a lot is your API 682. They recently had a 4th revision. How does that fall into this application? Where does API 682 guide or help or mandate, or what does it say?
Yeah, so specifically API 682 is a standard for recommended best practices for the design and assembly of shaft sealing systems for centrifugal and rotary pumps. And basically all that's saying is that it's just a recommendation. It's a standard that industry has set out there, and it's saying, hey guys, this is how we recommend you design, install, and build these systems. This is from a collection of industry experts who got together and they wanted to put together a common nomenclature, some sort of standardization across the industry, so that there's not confusion between different pump manufacturers, mechanical seal manufacturers. Getting us all on the same page in terms of lingo allows us to communicate effectively, and communication is the key to problem solving. So beyond that, you'll find in 682 recommendations for, tube bends and the type of tubing to use, wall thicknesses, do's and don'ts of installation operation, specifically where tubing is mentioned in the fourth edition. This, as you brought up, it is new in the fourth edition, and it's in basically section 8.2 of the fourth edition, where it talks about piping for seal auxiliary systems. But there's three tables, table 4, 5, and 6, that govern the details of these either pipe or tubing installations. And like I mentioned, tubing is now added and recommended per the fourth edition. It's lighter weight. The flexibility in terms of use is there. It's cost effective. It is a very viable solution. And while it's not a completely new way of doing things, just in the eyes of API 682, it's finally made it into print. And now it's officially recognized as a recommended way to install seal support systems for the fourth edition.
So we're pretty excited about that fourth edition coming out then, huh?
Game changer right there.
Update everybody's API books. So yeah, it's definitely changing with the times, but it's beneficial for all.
That's a big switch right there to go from it won itself to go from pipe to tubing on this.
Again, it falls in line with our principles. We like to minimize the potential connection leaks, and with piping, you just have more connections, so it's more opportunities for a leak, which of course can cost you money via lost process or regulatory issues. So
just improving that reliability.
Yeah, man.
So, Brandon, a little bit earlier when you were talking about some of the different seal support systems, you mentioned that there are some standard designs and then there are some more custom designs. So I know we have a catalog out there that has a lot of our standard designs. You can create your own part number and just order it that way as a customer if you'd like. But just about everything we do ends up being custom in some way, shape, or form. Yes. What are some of the benefits to being able to customize your seal support systems like we're able to help people do?
Yeah, of course. So, as we were putting together this seal support program and we were strategizing on, the market, the customer's needs, and how we could best serve our clients, a lot of feedback we did get was that this very issue is that, hey, a lot of our seal support systems are standardized. We have a design that we put in place. We got drawings and specifications. However, we have specific pump applications that either have a tight footprint, a special flow range. It's something that's outside of that standard panel. And what we found is that when customers try to change their panel standards, they ended up getting hit with longer lead times or excessive costs, or maybe not even being able to change them. So that was frustrating for them, and we saw an opportunity. So what we did is, of course, 682 is very well defines the systems in terms of the operational objectives of each of them. What we did is then took those systems, looked at what was available, and we essentially created not our own standards, but we created a Swagelok standard in terms of layout, operability, component selection, and basically just we put in some design principles of our own that we saw were advantageous for the operation, installation, and maintenance of these systems. Now, with that said, we built our standard to be configurable. And simply what that means is that there are several options for each specific plan. And I think we have a cool little image from our catalog we'll show here in a moment that kind of highlights that. But they are configurable in the sense that you can go in and create a part number, and that part number nomenclature corresponds with different options that are available within that panel. So have no fear if you go to our catalog and you check out the part numbers and your option or the customization that you want isn't listed, we can further go into that system and completely customize things.
And they can find all of that on the website right now if they go to sset.swagelok.com, right?
Correct. Yeah, you'll see the catalogs. The part numbers are very well laid out. It's pretty intuitive in terms of assembling your system. But the way that's advantageous for the clients is they can simply go to our catalogs and give us a part number, and then we can get something on paper quickly. We have configurable CAD files that align with these options. So each plan, we have a basic CAD file, and basically I just go in there, take the specific part number that's created based on the need, and I can then create a 3D model on the fly to provide clients an actual representation of what they'll be receiving. So again, this just kind of rolls into our full suite of engineered services and packages in terms of supporting the customer in the initial design, the concept, the modeling process, review and approval of CAD drawings, and then the final build and testing of these assemblies.
So that all wraps up into assembly solutions. You know, you mentioned CAD, you mentioned engineering, you mentioned, you know, a lot of times our customers, when we bring them something new, such as this, first thing they're going to do is, well, we got to do an MOC first of all. So we need to have all that information, and that's part of the whole package whenever you're doing this, right? The engineering done behind it, you get the CAD, you get the approval of the drawing. There's a lot to that, right? And so we have that full capability of design and CAD, right? And bill of materials, everything.
Correct, 100%. It's all locally done in-house. It's another advantage to working with Swagelok Southeast Texas is that it's designed locally, built locally, tested locally. Anytime the client, customer, partner wants to drop in and check on the panel, just have a quick conversation about the project, bounce some ideas off us. Our doors are always open. Of course, now in the COVID area, there might be a couple checks before you get in the door, but we are still available to consult and collaborate with our clients to ensure that every single detail is captured and that we provide them a project that's safe, reliable, and cost effective.
So on that same, we've got a little bit of a presentation that you sent to us, right? So is now a good time to go into that, or?
Yeah, we can roll through it really quick, and there'll be some things that we've touched on, but this will kind of give you a visual and I guess some more support in terms of some of the items we've talked about so far.
All right, so let's throw it up. Are we seeing everything? As always, we have Aubrey, our producer behind the scenes, letting us know when everything's running well or not. Are we seeing our Swagelok seal support presentation?
Yeah, I can see it.
All right, good. So you just tell me, we'll advance on that.
Okay, go on ahead. So yeah, this kind of just reiterates the function of a mechanical seal support system, as we talked about, lubrication of the shaft and seal, the provision of temperature control for the seal, basically moving the older fluid out and clean, fresh fluid in, helps control that temperature. Of course, we want to flush any seal or dirt or residue buildup off the faces of the seal. This protects against damage, scoring, things like that. And of course, again, something in terms of regulatory compliance, seal support systems prevent system media from leaking the atmosphere, and then also, of course, prevent any air from leaking into the system. So again, just a quick little rundown of what the seal support system actually does. And you can see that this particular seal support plan is taking flow from the discharge and recirculating into the mechanical seal chamber. So that's
very, very simple one here.
Seal support system there. Of course, that's a pretty little calendar there, but yeah, we've seen these before. Just basically a quick overview of all the plans that we can assemble for clients. And again, these plans that are detailed here are probably the panel with all of the options and bells and whistles, but all these things again are configurable. We can add or take away from the bill of material depending upon the application. Go ahead and hit the next one.
We do have these in wall chart form, so if any of you guys are watching and would like to stick one of these up in your office, let us know. We'll get them brought out to you.
Yeah. And so this is.
I just want to mention also, Brandon, before we get a little too far in this is not something specifically to Swagelok Southeast Texas. This is being done at a lot of our distributors, right? So,
Right.
If you're in a different location, you can contact your local Swagelok distributor and get this also, right?
Correct. Any Swagelok distributor will be able to supply and support services and systems.
Right.
Yeah. So this little snippet right here is this is probably what Jake and you guys talked about or spent the majority of your time on last week. And again, these systems are designed to work within the SEAL support systems, and of course they can be sourced individually and used in other various systems as well. But it's things such as just the integral orifice flange adapter. Basically, it's removing a piece from the puzzle. You don't have an orifice that is separate from the flange assembly. The orifice in it itself is in the flange. So you don't have any issues whether or worrying about the orifice being installed or losing it during disassembly. Thermal weld tees to reduce connection points, the extended male connectors, reducing connection points. You know, we are incentivized to help our clients reduce and eliminate leaks. And as you can see, it's emphasized through and through in terms of product development, our evaluation and advisory services through our on-site services group. We know that the customer's gas transmission is important, and we strive to, like I said, minimize the leaks and optimize their system operation. So you can go ahead and advance to the next slide. This is going to kind of showcase our CAD capabilities. Now, we can take ideas from a napkin. We can do a good old-fashioned walk down where we then come back into the office and create a PNID or a schematic layout as you are seeing right here. And this is where it all starts. We get an idea on paper, and then we move it to a CAD assembly where we can fully model this in three dimensions and then provide a completed bill of material along with dimensional drawings to the customer so they can approve after, of course, reviewing and making any comments they might have. So again, this is highlighting the collaborative process that the engineering team within Swagelok Southeast Texas and our clients will embark on when we are building these panels. And then as you go to the next slide, you'll see the final product.
There we go.
There we go.
And then that's the final product there. So at that point, we would then call up the customer and we would do a on-site test, or we can do a virtual test now through Teams or a Zoom call or WebEx, whatever the preferred method is. But we can do a pressure test, a functional acceptance test. We have other testing options available depending upon the circumstance. But as you can see, this particular application, you know, we did it the old-fashioned way. Buster and I actually went to the customer site. We walked it down, checked out the layout, found out what intentions they had, you know, any problems they had with the current system they wanted to either remove or address on this new system. And we put together a system with the customer. And this was the final product. And, you know, they're pleased. It's operating. Their mechanical seals being serviced, and it's nice and cool and dry and clean. And, you know, that's just pretty much a start to finish example of what it looks like going through the assembly solutions process. And again, this is not just specific to SEAL support systems. This is for any custom assembly solution that you may have that requires moving some fluid or gas from one point to another. The page we got up here is just an example of the catalog that you'll see. Now, each API plan has one of these. Again, Buster mentioned you can go check these out on our website at swagelok.sset.com. But every plan, as you can see, is laid out. We list the components that are inside of this kit, and then there's a PNID that shows all of the available options. You would then, of course, look at your specific application, determine what you need, and you could go over to the next page, which is the part numbering portion of the catalog page. And essentially, you can see that each one of these part numbers, the nomenclature corresponds to different options. So you can go through and knowing the details of your SEAL support system, you can spec out your SEAL support system with this part number, contact us, and then we immediately know what you're talking about, can put together a quote for you rather quickly, and then start the process. So again, standard designs with configurability. So that's a value that Swagelok Southeast Texas is bringing to the table. While we understand we want to have the standards to control lead time, cost, inventory, things like that, we also want to give our clients the flexibility they need to act quickly.
Looks like we also got something else that slipped in here, a seal panel fill cart.
Yeah. So this is, another example of just our CAD work and what the customer gets before or prior to build. We always want to make sure that clients review and approve the design so that therefore, as we start production, there are no change orders, hiccups, delays, things like that. But yeah, as you mentioned, Buster, this is an auxiliary component that would service a seal support system. And essentially it's a seal pot fill cart. So technicians have to go around from time to time, preventative maintenance, change out, or just topping off of process fluid that is used in mechanical seal systems via seal pots. And essentially, it's a pot, it's a vessel, it holds the fluid, and it's either non-pressurized or pressurized by nitrogen. And that pot essentially feeds the seal support system. Over time, that process fluid could leak back into the collection system. It could be lost through a leak or some other, some other forms of dissipation or evaporation or whatever might happen in terms of the system losing fluid. But this fill cart system allows you to safely and efficiently take out whatever the process fluid may be to the specific pump site and top off that seal pot without having to get a ladder or a bucket or things like that. That seal fill cart has a quick connect, so you just hose it up to the seal pot, pump her up, and then you're good to go.
And you're able to use one of these quick fill tubes for seal pods, or this can be done aftermarket, right?
Correct. We can retrofit any seal pot or any current seal pot installation and add these quick fill tubes. And again, this is a safety component. There's some efficiency that's some realized from installing these. But again, this is basically the quick connect at the bottom that you would hook up that seal fill cart to. So again, you're making one connection. You hand pump it up, pressurize, top off, or fill your seal pot, disconnect, and you're on to the next one. Whereas in the past, without the quick fill tube, you have to get a ladder to undo the top bull plug on the seal pot, fill from the top, off the top of a ladder, maybe from a bucket. It's not as safe, it's not as fast. And so we've seen a lot of success with these quick fill tubes and the seal fill cards. A lot of people like them, and it's a easier, quicker, more efficient way to do something that's necessary in terms of maintenance.
All right. So I want to run through, I think we got a few more little slides here on some of our capabilities.
Yeah.
This is a Plan 53A, but it was customized specifically for the customer.
This one's a Plan 12. I'm sorry.
Oh, my bad.
Yeah, so this is a Plan 12, and this was a particular application where a customer was having trouble with their standard Plan 12s. And what we did is we worked with them, understood their flow rates, understood their pumping application, and we essentially gave them a beefed up version of a Plan 12, and it's been very successful as well for them.
That looks pretty slick right there.
Yeah, and that was a big headache for them because they were having lots of issues with that pump failing, and they had identified the seal support system as the culprit. So again, it shows you that while we look at the seal support system as an auxiliary, and it's not the bulk of the spend on a pump system, it is critical to the life of the pump in your mechanical seal.
Yeah, absolutely.
Yeah. Here's an example of one of the fill. I'm sorry, I'm going.
Fill tubes.
Yeah, the fill tube connected.
Yeah, that shows the entire picture there. This is a pressurized seal pot system. And this is showing you our configurable CAD models. So as you can see, this one has transmitters, ball valves, has the quick fill tube, has the flange on the bottom of the pot. We could quickly go into our configurable CAD model, change the part number, drop the transmitters, change the bottom flange to an NPT connection, and remove the quick fill tube. And that's just demonstrating how quickly we can model these systems. But again, yeah, this shows you the quick fill tube as it's installed on the pot. And as you can see, it takes the connection point from what might be anywhere from 5 to 6.5 foot in the air and brings it down to the waist level of that, the average size person there. So again, it's increasing the safety and efficiency when your guys are out there or the technicians are out there filling these pots.
And then also another plan right here.
Yeah, and here's another example of a final assembly, just a Plan 74, nice and panel mounted. See, it's a clean mount. The system's laid out in a way to ease operability as well as maintenance. Of course, the worst thing in the world is to get a panel out in the field and you not be able to work on it at all because you can't take it apart without disassembling your entire system. But we try to take all these factors into consideration when designing and laying out these panels to ensure that all works out for you. So, yeah.
Well, Brandon, man, we've covered a lot right now. We're kind of come up to the end of our half hour here. So just want to say thanks for joining us. We appreciate it a lot, man. And we're going to wrap it up and we're going to tell everybody how to find us for these. So thank you very much.
And we'll have you back to go into more detail on some of the things we talked about on those slides for sure.
Yeah, for sure. Anytime. Maybe we can spend a little more time on those seal fill carts and the quick fill tube assemblies to kind of show some variety in what those installations look like.
Yeah. Sounds good. All right.
All right, guys.
Thanks, Brandon.
So, guys, just to kind of wrap this up, speaking from a real world experience, when we're out in the field and we're talking about a lot of the things that we just talked about with our customers to upgrade their seal systems, from my own personal experience, I've worked on several of these applications where the customers have your typical seal flush system. It's done with pipe. It's kind of been there for a while. And when we went with the upgrades and we started going by the API 682, we started switching to tubing, using our components. The feedback that we received was, man, this is going a lot faster and easier than our typical experience with this. So if you do have maybe some trouble systems that you want some help with, contact us. We're here for you. So, Logan?
Yeah, so great way to sum it up there, Buster. And yeah, I'll just kind of echo that. So whether it's the components that Jake talked about a couple of weeks ago or the entire systems that Brandon mentioned today, we're here and we have a lot of different stuff that can help our customers out on these seal support systems or with their rotating equipment. So, everything that we do with all these, it's done local, it's highly configurable, as Brandon talked about. We're not going to try to push you directly to a standard design. We have them, but we're highly configurable and everything's done with the utmost reliability in mind. So those are the main points of letting us help you out, and we're here and we're happy to do that. And like I said earlier, we will have Brandon back on to go in more detail about the seal fill carts and the seal fill tubes, because those are a couple things that a lot of our customers are very interested in. So thanks everybody for tuning in. Thanks Brandon for coming on. Next week we are going to have Leah Keel on to talk about VMI, vendor managed inventory solutions. But please don't wait for an episode for us to talk about something that you'd like to hear about. Feel free to contact us directly, either Buster or I or your local salesperson. And please let us know if there's anything that you would like us to cover on this show.
Yeah. And as always, guys, go ahead and follow us. We're on Facebook, Instagram. Now we're on YouTube. So go ahead and click that little subscribe button down at the bottom. And go to our website at sset.swagelok.com to where you can find all the things we're talking about in these series right then and there. Guys, have a great week, and hope that the weather doesn't get you all too bad. Later, Logan.
Later, Bus.